Hello and welcome back. If you're watching this as part of the video series for the AP Chemistry homework for Mr. Stevens' class here, it's May 6th. It's the common ion effect in pH and solubility. So we did problems with the common ion effect in videos 1 and 2. So take a look at those if you're interested. I would recommend starting there before moving on to this pH component. The pH component here, so we're looking at 41. So iron hydroxide is ionic compound, and its KSP is 4 times 10 to the negative 38, super small. And it wants us to know the molar solubility in a couple scenarios, and the first is water. So we'll take a look up, we'll first set up the rice table, just because that's familiar to us, so that we can see where we're at. Okay, so hopefully you can see that I set up my rice table, and it's almost complete. So obviously this is pretty much staying the same if it's a solid. We're assuming that, and the iron ion, cation, there's nothing at the beginning in the solution when you just add it in, and it increases by 1s, and that kind of makes sense. But here the hydroxide ion, so it increases by that 3s, and that's all prepared, but the initial concentration, is there initial concentration? So here we kind of have to look at a somewhat of a new idea that called the autoionization of water, and so we'll take a look at that. Okay, so the autoionization of water basically is a concept that regular water just chilling, say in a glass, beaker, whatever, ionizes into hydronium, which is, remember, acid, and hydroxide ions, the base. And this is a equilibrium expression, and it's represented by Kw, and it's equal to the concentrations of hydronium times concentration of hydroxide. So that's kind of where we're at and how we start. And this Kw value is 1 times 10 to the negative 14. So it's very small, but compared to our problem, which is 10 to the negative 38, that's even smaller. So that's why I'm going to come down here to consider it. So when you do your Kw expression, you could substitute in for, you could use S here for the solubility of water in itself, I guess, but it's easier just to put in X here. Kw equals X squared, fill in the values and solve, and that 1 times 10 to the negative 7th equals X, which equals the concentration of hydronium, and also the concentration of hydroxide ions due to the autoionization of water. You can fill that in that molar. So we can use that in our ice table. Okay, so I brought up the concentration of hydroxide ions from the autoionization of water down here, because that's an initial value that's already in there. We still increase by 3s, that hasn't changed, and so our valued equilibrium is that amount of hydroxide ion plus the increase due to the addition of the iron hydroxide. So that's equilibrium. So now we can move into our KSP and those values, and using this expression just kind of as normal. So I filled in those values here, and again the S, because we have such a tiny value here, negative 38, this is going to be negligible, and I'll note that here. So I noted the negligible X here for in this expression when we filled it in, and that's because the KSP is so very small, and this is to make our math easier. So this is such a small value when it comes to ethanol that really doesn't matter for us to include it in calculations. We'll get close enough so you can drop it out so that you can actually do the math without going cray here. So I just filled in the values here after dropping the 3s, and then obviously we want to solve for s. Okay, and to finish this out, like I said, the negligible x factors in here, so we drop this 3s to make our math simpler, solve for s. So the molar solubility of iron hydroxide in just plain water is 4 times 10 to the negative 17th molar. And the common ion effect and pH plays in here because of the fact that we have OH as an ion. And OH is naturally produced by the autoionization of water, and thus we have an ion already present, and we have to factor it into our rice table in our calculations. That's why we ended up where we ended up here with these values. Again, please reach out via email, message me if you have questions. Thanks.